Alrighty, in this clip we're going to be looking at how to solve problems involving parallel lines cut by a transversal. Alright, so let's take a look at question 1. It reads, in the diagram below, line FAD, that's line on top, and line EHC are parallel, okay? So line FAD is parallel to line EHC, and ABH, segment ABH and BC are drawn. Question. If the measure of angle FAB is 48 degrees and the measure of angle ECB is 18 degrees, what is the measure of angle ABC? Okay, so let's go ahead and mark the angles that were given. So angle FAB, this is 48 degrees right here. And then angle ECB, this angle right here is 18 degrees. And we are to find angle ABC, this angle right here. All right. So in order to solve this problem, there are three things we want to go over. All right. So we're going to go to our website. So if you go to mathgotserved.com and just click on geometry, and then we're going to scroll down to our vocab collection. All right. So we're going to take a look at two vocabulary terms and one theorem. So the first vocabulary term we're going to look at is linear pair, number 12. So remember the linear pair postulate. Basically, if two angles form a straight line, they are supplementary, or they add up to 180 degrees. Okay, keep that in mind. Let's go back home. And then alternate interior angles. Whenever you're dealing with parallel lines, like line 1 and line 2 cut by a transversal, angles that are on different sides of the transversal are called alternate, okay? But if you're in the interior, the region bounded by the two parallel lines, that's interior, the angles on the opposite sides of the transversal are called alternate interior angles. All right, so what you want to keep in mind is that if you have two parallel lines cut by a transversal, alternate interior angles are congruent. The same also applies to exterior angles too. Okay? All right, so we have two things to note. We're going to revisit these points when we are doing the problem. And then the last thing to highlight on the theorems is the triangle angle sum theorem. So don't forget, the sum of the interior angles of a triangle is always 180 degrees. All right, so let's go over the plan for solving this problem. We're going to be implementing those three things we just talked about. So to do this, this is the final angle we want to figure out, ABC. Let's call that angle, let's call it, how about call it angle Z, okay? So call this angle Z, doesn't really matter what you call it. This is Z. So in order to find angle Z, we have to go through a sequence of steps. All right, so we have these two parallel lines cut by a transversal. So if you have two parallel lines cut by a transversal, this angle right here, there's a special relationship between this angle and this angle. Let's call this angle down here, let's call it angle X. Okay, so first of all, we're going to find angle X, and then we have a triangle here. With this triangle, we can find this angle on top here. Let's call that angle Y. Okay, and then using Y we can find Z. Okay, so let's go ahead and outline the steps to help us solve the problem. So step number 1, we are going to find X. All right, using the idea that alternate interior angles have a special relationship. Alternate interior angles. And then number 2, we're going to find Y using something called, we just looked at it, the triangle angle sum theorem. All right, and then lastly, we're going to use X and Y and this measure 18 right here, we're going to use it to find Z. Now Z is what angle ABC is, okay? And then what we're using there is going to be the linear pair postulate. So linear pair. Okay, let's go ahead and get started. Let's do part 1 first. So part 1, we're going to find x. Okay, using the notation here, x is basically we're looking for the measure of angle AHC. AHC. Okay. All right, so what do we know here? Well, the relationship using the alternate interior angles approach, we know that the measure of angle AHC or x is equal to the measure of angle FAB. Right? X is equal to the measure of angle FAB. How do we know that? We know that because alternate interior angles of parallel lines cut by a transversal are what? They are always congruent. So we automatically know that this angle right here and this angle, they are congruent because we have, see, AH is the transversal, okay? And this line FAD is parallel to EHC. So you have two parallel lines cut by a transversal, alternate interior. So this region here is the interior, all right? So if you're on the different sides of this transversal AH, then you're alternate, okay? So alternate interior angles of parallel lines cut by a transversal are congruent, all right? So since the measure of angle FAB, it's given to us, is equal to, what is it, 48 degrees, and measure of angle FAB is equal to x, that automatically follows that x is 48 degrees. Voila. So we have part of it done. This angle right here is 48 degrees. Bam. Part 1 down. Now we're going to move to part 2. We're going to use these two angles in this triangle to figure out y, or angle HBC. Okay, let's move on to that part. So for part 2, we want to find the variable y, which is equal to the measure of angle HBC. All right, so what's the relationship between x, y, and 18, or x, y, and angle ECB that we can use to solve for y? It's the triangle angle sum theorem, right? We know that x plus y plus the measure of angle ECB, all right, the sum of the interior angles of a triangle is equal to 180, and that's by the triangle angle sum theorem. Bam, we know all of this. So we're going to substitute here. We're going to create an algebraic equation and use it to solve for y. Okay, let's substitute what we know. We know that x is 48. How do we know that's what we found in part 1? 48 plus y plus the measure of angle ECB that was given to us as 18. All this add up to 180 degrees. All right, let's combine like terms on the left side. 48 plus 18 is 66, so y plus 66 is equal to 180. All right, to get y by itself, we just simply subtract 66 from both sides. We're flexing our algebra muscles now, what we learned last year. So we're now going to have y by itself. 180 minus 66 is 114 degrees. That's what y is. Okay, so y is 114. Now the last part is to find z. Z is the measure of angle ABC. So for part 3, we're going to find z. Z is the same thing as the measure of angle ABC, what we're asked to find. Okay? So what's the relationship between Y and Z? They form a linear pair, right? So we looked at the relationship between a linear pair of angles earlier on the website, mathgotserved.com. So we're going to restate it again. Okay? The linear pair Y and Z, Y plus Z are linear pairs, so they're supplementary, so, which means they're equal to 180 degrees. All right, based on a linear pair postulate. So we're going to substitute. What do we know in this equation? We know that y is 114. We found that in step 2. 114 plus z is equal to 180. To get z isolated, we subtract 114 from both sides of the equation. Bam, bam. And then our final answer, z, is equal to 66 degrees. Okay? So basically the measure of angle ABC, what we're asked to look for, which is the same thing as z, is 66 degrees. Ladies and gentlemen, the answer to question number 1 is option number 3. That's your answer right there. Okay? Thanks so much for taking the time to watch this presentation. Don't forget to help support our channel. If you have any questions on what we just went over or any geometry concepts in general, just specify it in the comment section below and we'll be more than glad to support you. Thanks again for visiting our YouTube video, and we will see you in the next presentation. Take care.